In question 3, we are given a whole host of information about a college and the 80 students that it has in year 12. And there is a lot of information here about biology, chemistry and physics. And we're asked in the first instance to draw a Venn diagram to represent this information. So if we've got 3 subjects, let's just set up our Venn diagram. So this is going to be the universal set comprising 3 subjects of biology, chemistry and physics. So we're going to label those biology, chemistry and physics. With these questions, the key is always to start in the middle. So we're told that there are 3 students who study all 3 subjects. So that's going to go in the middle, which is the intersection of biology, chemistry and physics. And then you can just work your way out from there. So this section here is the intersection of biology and chemistry. So we know that in total there are 7 students who study both biology and chemistry, but 3 of them already here. So 7 minus 3 is going to give you 4, so that's going to be there. If we have a look at this intersection here, this is the intersection of students studying chemistry and physics. We know that there are 11 students who study chemistry and physics, but there are 3 here, so we're going to do 11 minus 3 and we're going to get 8. So we can work out this region here by figuring out that in total there are 28 students who study chemistry. So if there are 28 students who study chemistry, we've got 4 here, 3 here and 8 here. That's going to give us 15. Therefore, there must be 13 students who only study chemistry. So we can do that for each of these, and we end up with this. And you'll notice that if you add everything up here, you don't actually get 80. So that must mean that the difference is going to be students who don't study biology, chemistry or physics. So if you add this all up and subtract it from 20, you will realise that there are in fact 22 students who aren't taking any of those subjects. In part B, we are asked to find the probability that the student, or year 12 student chosen at random, studies chemistry but not biology or physics. So this is all the students who study chemistry. We can see that, these students here study biology and chemistry. These students study physics as well. These students here also study physics. So the only students who study chemistry but not biology or physics are going to be these 13 here. So we're looking at 13 out of the total number of students in the year, which is going to be 80. In part C, we're asked to find the probability that the student studies chemistry or physics or both. Now, a couple of different ways of doing this. First of all, looking at the Venn diagram then. The probability that the student studies chemistry or physics or both. So that is, in effect, anyone in this region here. Yeah, anyone in this region here is going to study chemistry or physics or both. So the simplest thing you can just do is to add up all the numbers here, and you will end up with 47 over 80. The other way you could do it is using the complement. So we can see that the only things not included here are 11 and 22. So if you add those up, you get 33. Subtract those from 80, and you'll also get 47 over 80. And another way that you could work this out is using the formula. So the formula you might recognise is the probability of physics or chemistry is going to be the probability of physics plus the probability of chemistry minus the probability of physics and chemistry. And if you do that, you'd get 30 over 80 plus 28 over 80 minus 11 over 80. And that is also going to give you 47 over 80. So quite a few different ways you can work that one out. When you read part D, you might well look on with alarm when you read this key word here, because given is a code word telling you that you are looking at the conditional probability here. And conditional probability is something that normally strikes fear in the heart of most stats students. However, this one's fairly straightforward. All you're asked to do is, you're told that given that a randomly chosen student studies chemistry or physics or both, find the probability that the student does not study biology. So we have seen in the previous question that the probability that a student studies chemistry or physics or both, we're looking at any student in this region here. Okay, so the conditional probability means we're only looking at those students. So now, instead of looking at all the 80 students in the year, we are only going to be looking at these 47 students. So that's the condition. We're only looking at these students. So that's going to be our new population or our denominator. And we're asked to find the probability that a student does not study biology. So we can see that the only students that do not study biology are going to be these 13, this 8, and these 17. So we are just going to add those together, and if we do that, we will see we get an answer of 38 over 47. There are a couple of different ways that you could do part E, which is asking you to determine whether studying biology and chemistry are statistically independent, but the most straightforward is recognising that if these two subjects are independent, the probability of choosing biology given that you're studying chemistry will be the same as the probability of choosing biology. Because essentially what you're saying here is it makes no difference whether or not you're choosing chemistry. If these two events are statistically independent, it doesn't matter whether or not you choose chemistry, the probability that you choose biology is the same. So in effect, then what you've got to do is calculate each of these and hopefully you will end up with the same value. So in the first instance then, if we want to find the probability of B, the probability of a student reading biology given that they choose chemistry. So again, we've got conditional probability. So this is the conditional, or this is the condition here. The condition, they study chemistry. So we're only looking at these students here. So if we're only looking at those students here, what's the probability they study biology? Well, it's going to be these 7 students here. So the probability of that a student studies biology given that they study chemistry is going to be 7 over 28, which is therefore equal to a quarter. The probability that a student studies biology then. So we know from, well, either from this information up here or from the Venn diagram that there are 20 students who study biology. So there are 20 students who study biology out of a total of 80 students in the year, which also simplifies to a quarter. So given that these two values are the same, we can say that studying biology and studying chemistry are statistically independent.